Today we are solving the problem 1 from 1984 International Mathematical Olympiad. The problem is to prove that the expression xy plus yz plus xz minus 2xyz is greater than 0 and less than 7 over 27, where x, y, and z are non-negative real numbers for which x plus y plus z equals 1. This is a classic inequality problem. Problem 1 is usually the easiest one, and 45% of the participants solve this problem. Let's solve the problem. Since x, y, and z are non-negative and their sum is 1, we know that the value of each number is between 0 and 1. Now we prove that this expression is greater than or equal to 0. Since x, y, and z are non-negative numbers less than 1, x, y, z is less than or equal to any of these pairwise products, x, y, or y, z. From these two inequalities, and we know that 2xyz is less than or equal to x, y plus yz. Adding xz to the right side still holds the inequality because xz is also non-negative. Rearrange the inequality, and we get 0 is less than or equal to xy plus yz plus xz minus 2xyz. Now we prove the remaining part of the inequality. The expression is less than 7 over 27. We multiply three expressions, 1 minus 2x, 1 minus 2y, and 1 minus 2z. Expanding the first two brackets gives 1 minus 2x minus 2y plus 4xy. Then expand these two brackets to get 1 minus 2x minus 2y plus 4xy minus 2z plus 4xz plus 4yz minus 8xyz. We can rearrange this expression as 1 minus 2 times x plus y plus z plus 4 times xy plus yz plus xz minus 2xyz. We know that x plus y plus z is 1. This expression is negative 1. This expression is the same as the original expression. Now we apply the AMGM inequality. For non-negative numbers, the geometric mean is always less than or equal to arithmetic mean. Applying AMGM inequality, we get the product on the left side is less than or equal to 1 minus 2x plus 1 minus 2y plus 1 minus 2z, all divided by 3 the whole cubed. Negative 2x, negative 2y, and negative 2z add up to negative 2. Simplifying this expression gives us 1 over 27. So the left side of the expression is less than 1 over 27. Add 1 to both sides, we get 28 over 27. Finally, divide both sides by 4. Now we have the required inequality. The expression is less than or equal to 7 over 27. We apply AMGM inequality for non-negative numbers, but we need to account for cases where some of the numbers might be negative. Without loss of generality, assume that 1 minus 2x is negative. This implies that x is greater than 1 over 2. Since the sum of x, y, and z is 1, it follows that both y and z are less than half. Consequently, 1 minus 2y and 1 minus 2z are positive. Only one of the three numbers can be negative. In this case, their product is negative, which means it is still less than 1 over 27, and the inequality continues to hold. Therefore, the upper bound of the expression is 7 over 27, and the lower bound is 0. This completes the solution.